Have you seen the soft dinosaur cells?
Huh? What?
Soft dinosaur cells. Real cells. Have you seen them?
Oh, be very, very careful.
Wait, there are soft dinosaur cells?
Yup.
No, you're lying.
Nope.
You're lying. Really? Think with your brain. Yes, folks, dinosaur bones are full of soft tissues. Scientists have found soft dinosaur tissues in T-Rex bones, in Tarbosaurus, which is like a T-Rex, in Brachylophosaurus, which is the dinosaur that had kind of the friar's head, kind of the bald but hard bone head, and what I've been working on, which is Triceratops.
This is so exciting. That is why we have to share it with you.
So we're going to show you how to find some of these cells. In fact, I have a microscope here, and on the microscope I have a fancy monitor. And here, if you see on the monitor, you'll see a cell, and that's actually a dinosaur bone cell that was collected from this Triceratops horn. So what we hope to do is to teach you how to make microscope slides with dinosaur cells on them, like the one you see here. Of course, one of the most stunning and exciting finds from our trip to Montana was this soft tissue that I'm peeling away from the bone. These sheets of soft fibular bone that were full of the kind of cells that you're going to see as we progress through this little tutorial, but they're full of plant roots, and yet they had cells in them. Yes, I have a lot of fancy equipment. And the beauty is that I'm able to show you, by shooting through these pieces of equipment, some beautiful microscopy. And that's going to be our goal in this YouTube channel. But I'm going to show you the kind of microscopes that you can use to do the kind of work that we've been doing and find these kind of cells. Let's discuss what you're going to need to do this experiment. First, you're going to need glass slides, and buy good quality slides that don't have grease or oil on them. Make sure you buy glass cover slips, a number 1 or a number 1.5, but you're going to have to wash these. So in order to wash them, you'll need plenty of distilled water, and you'll also need Kim wipes to dry them when you're done, and finally a compressed can of air to blow off any debris that's still on them. Now you're going to need the solutions in the bottom of your vessel from the decalcification, because that's what you're going to pipette out after these have soaked for a while. So you will also need some pipettes. I like to use glass Pasteur pipettes. And also you need a vessel to put your solutions in after you take them off the bottom of your soaking vessel. Finally, you're going to need a good high-quality compound light microscope to examine your slides after you've made them. There's one other thing, I'm forgetting something. What is the other thing that we need?
Only a simple-minded person would forget that you need a dinosaur bone.
For once he's actually right. We do need a dinosaur bone.
I know where we can get such a bone.
Thank you, General. Thank you for the bone. He's enthusiastic, isn't he? Well, it's an interesting bone, but not what we want to work with. What we want to work with is dinosaur. And so here I have a piece of a Triceratops horn that was broken off of the horn, and we're going to soak this in a weak acid. We'll go step by step, and the goal is to soak this and get all the minerals off of it. Picture a piece of concrete, a concrete slab with plumbing inside of it. We want to melt away the concrete and get to the plumbing, because that's where the soft tissues are. And eventually we'll get to the point where you have a solution that you can pipette out onto a slide, and you'll have a dinosaur bone to look at under your microscope. Here now is a piece of the Triceratops horn that has not yet been soaked in a weak acid or decalcified. It's like a concrete slab. There's a whole bunch of concrete that we want to dissolve away. If you notice all these little holes, these are blood vessel openings where they come to the surface of the bone. And so we're going to soak this in a weak acid to uncover the plumbing that we want to find inside, because that's where the soft tissues are. Now after soaking it, it looks a little different. You soak this for a few weeks and put it back under the microscope, and now you can see all the blood vessels. The concrete has been dissolved away, and you see all the blood vessels that are left. And it's on the surface of these blood vessels where we find the tiny little cells. And as we zoom in, take note of the little white dots. The white dots are actually the bone cells laying on the outside of the vessels. They're soft tissues coating or surrounding the outside of the blood vessels, and you can see these little tiny white dots. Those are the bone cells that we're going to image under the compound microscope. So you're going to have to soak your bone for quite some time to expose these soft tissues. In order to understand bone and bone cells a little better, consider this tarp laying on the tarmac to be a sheet of collagen fibers. The osteocytes, or bone cells, come in and lay themselves down on the sheet of collagen in a very specific conformation. They're parallel to each other, and they're aligned in a way that they're all touching each other. Then two specialized bone cells, called the osteoclast and the osteoblast, come in, and they lay down a layer of bone over the osteocytes, or bone cells, cementing them in. The bone cells are still alive, but they're completely cemented in, and this is the way your bone is built up layer over layer. It is also said that your skeleton is actually recycled every 12 years. And so the osteoblast and the osteoclast come in and they constantly peel away layers of bone, exposing the osteocytes, and then they cover them with a new layer of bone. In this way, any cracks or deformities that form in your bone are repaired. And this is a constant process as long as these bone cells are alive inside your living bone tissue. So let's go through the steps on doing this experiment. Hopefully by now you've had bones soaking in your weak acid for some time, maybe several weeks, even months, and you're going to pipette out from the bottom of the container the solution with the cells that are laying on the bottom. So you want to run your pipette along the areas where you see material on the bottom of the container, because that's where the cells are. Once these are removed, you have them in a vessel that you can then make your slide from. It's very important that you work with clean slides. So take your slides that you've purchased and wash them in distilled water, spray each side, and then use a Kim wipe or a Kleenex. Kleenex is good, but it sheds a lot. Kim wipe doesn't shed a lot. Well, make sure it's completely dry, and then you're going to hit it with some compressed air, and that will remove any remaining pieces of material that are on the slide so it's nice and clean. Set it aside on a clean Kim wipe. Do the same now with your cover slip. You're going to wash it with distilled water. Now these are very thin and they're easy to break, so you want to apply equal pressure from above and below with your two fingers. Be careful not to apply any pressure that may be different on one side to the other, because you'll crack it right in half. So once this is nice and clean, set it aside and leave it for the next step, which is making the actual slide. Now you're actually ready to make your prepared slide. So you're going to pipette out a small amount from the bottom of your vessel onto the slide. Make sure you select from an area that has material. Put your water droplet on the middle of the slide and move it around in a circular fashion. Don't make the water droplet too big. Now you're going to take your cover slip and you're going to touch your cover slip to the edge of the water droplet and lay it down gently. So one edge touches down, and then you lay the cover slip down, let it fall under its own pressure, and now you need to wipe up the excess liquid on either side of the cover slip. So use a Kim wipe to dab that up carefully. Try not to move the cover slip, because now you have cells under there. And in this way you have a slide that's ready to be looked at under the microscope. Now you're ready to examine your slide under the microscope. Put your slide on the microscope stage. Make sure that it's clipped in place so that you can move it around if you have a mechanical stage. Turn on your illumination, and I would start with a 10x objective and go up from there. Now, you may not be able to go on a dinosaur dig for whatever reason and find a triceratops horn like we did. It was very exciting. But money is tight and schedules are tight, but you can do the same experiment using cow bones. If you go to your local meat market or grocery store and ask for some sliced marrow bones, This same experiment that we're doing will work on that, same as it did on dinosaur bones. So email us at micromark@juno.com if you have questions. Those last 3 videos showed the cells a little bit out of focus, so I thought I would go all the way up using my 100x oil immersion objective and show you this beautiful cell with all of its beautiful and delicate filopodia at the highest possible magnification. Don't forget, folks, about our new book, Old Stretchy the Dinosaur Bone Cell and the Adventures of the Triceratops Horn. Deborah, Liz, and I are very proud to have done this book. It's a 25-page book, fully illustrated, comes with a free DVD inside, and it shows the dig, it shows the results, all the different bone cells that we found, beautiful pictures of the bone cells. And so if you're interested in a copy, please email us at micromark@juno.com and we'll give you details on how to order the book.
What is your name?
Dino!